Hello everyone. In this lecture, we are going to send the data of our ultrasonic sensor to ThingSpeak account and using NodeMCU we are performing. It is completely similar to the previous experiment where we have done with the DHT11. There what details we have shared temperature and humidity. Here also complete process is same but only the main code nothing but not with ThingSpeak or with NodeMCU. Only the sensor code we are going to alter. And what data I am going to send is why actually we use ultrasonic sensor for the distance measurement, right? So for distance, one field I will take and one more. We are going to get distance by calculating with respect to duration. And how you get duration is due to echo. What do you mean by echo? Sound. Here we are going to consider speed of sound in air and we are going to obtain the formula for calculating the entire distance. If you want to know more about this ultrasonic sensor, in the description of video I have attached the link where we have discussed the ultrasonic sensor interfacing with Arduino Uno. There I have explained more about this sensor. Now let us see firstly regarding the ThingSpeak. So log into your ThingSpeak account, guys. Firstly, yes. In previous lecture, we have used this DHT11, right? Even now, you can use within this channel, and you can consider any new fields or for same fields also you can send data. It's not an issue. But I want to maintain a new channel. Let me name it as ultrasonic sensor receiving distance and duration from ultrasonic sensor and NodeMCU ESP8266. Yes, two fields are needed. First one, let me maintain for duration. Second thing for distance. Yes, two fields are set. Directly you can go down and click on save channel. Yes, now go to sharing. Just a second, it is loading. Yes, in sharing, click on share channel view with everyone and now go to public view. You can see this channel was set to public. Now let me explain you the code. Here coding part I will teach faster because anyhow complete thing was taught in DHT sensor and ThingSpeak program, nothing but the previous lecture. So here you are considering the ESP8266. Yes, this one from board manager you need to install. Yes, this one you need to install for the first package. For the second package, you need to click here ThingSpeak. Yes, ThingSpeak by MathWorks you need to install for getting the second package. Here we are not required DHT.h file because we are now working with our ultrasonic sensor. Remember guys that one. Yes, Wi-Fi ID, Wi-Fi password. Coming to here, channel ID and API key. Yes, this time I need to change because those are regarding my DHT. This is my channel ID. Copy this and here you need to update it. Channel number. Next, this is also right API key because since we are just displaying it, click on API keys. Yes, copy this right API key and let me keep it in public view itself. Yes. Now here I have pasted my new API key. Yes, we are having completely 4 pins for an ultrasonic sensor. 2 pins are always common, VCC and ground. VCC nothing but positive to be given to 3.3 volts and negative or ground pin should be given to ground of node MCU. Big pin and echo pin. In this both pins, echo pin acts as input because echo is nothing but sound, right? The resound or something, right? It is considered here as speed of sound in air actually. And trig pin is going to be our output, which is used to get the distance. So for that you are going to declare pins, GPIO pins D2 and D3. Now this complete thing is same, Wi-Fi client. Nothing but we are checking for the Wi-Fi connection. You have started the serial monitor, and here regarding the sensor you have given details like it should be input and it should be output. Yes, nextly we are going to begin our Wi-Fi by passing the SSID and password, and you are saying connecting to Wi-Fi, and if Wi-Fi status is successfully connected it will print as connected, otherwise it will print as not connected. This complete part is same. If you remove also nothing will happen, but see that there is a Wi-Fi network. Next thing is we are going to begin our ThingSpeak. ThingSpeak dot begin of client. Now coming to the loop function, we are giving float because distance always there is no chance to be exactly in integer. So one is duration and one is distance. To make the echo pin work perfectly, we are going to alter the trig pin initially. But here microseconds. If we use only delay, it is milliseconds. Milli means 10 power minus 3 seconds. Micro means 10 power minus 6 seconds. Yes. Now coming to the duration, we are going to take input as pulse. That's the reason the function already it is existing in Arduino IDE is called pulse in. Yes, pulse for what pin we are doing? Echo pin. Yes, it should be high. Yes, here while altering trig pin, once you need to alter by keeping it at high range and once with low range. Yes, don't do first low and then high. Finally, it should be low. Remember that one. Now you are going to calculate distance based on duration. And here you can see this value, right? 0.343. Yes, 0. Nothing but some 0.0343. The reason why we have considered that number is speed of sound with respect to air. We have considered that one. And on serial monitor, I am going to display these things, duration, and one more is going to be distance. Now in ThingSpeak, I have set the fields. One is for duration, first one, and second one is for distance. Now I am considering the response. ThingSpeak.write fields, I am passing my channel number and API key. And nextly, here you can see, right, response 200. Nothing but if successfully data is uploaded, you will get this message. Otherwise, you are going to print this one and you are going to show which kind of error you are getting. And as I told, ThingSpeak takes minimum 15 seconds. So you need to give in delay 15,000 or more. That's it. Now let us see the hardware components. Before that, just let me enter my Wi-Fi password here. Yes, I have entered my Wi-Fi password successfully. Now let me compile this one. Yes, there is no error now. So let me upload the code with respect to our NodeMCU. I will also show you the connections. But remember that one trig pin to D2 and echo pin to D3. And in the next lecture, we are going to work with by considering the cloud platform, Microsoft Azure. With Azure, we are going to work. And once the sensors, there we are going to do for IR and LDR. Once those two are over, then we will start into the main projects, which you can also add to your resume. Hope you all understood, and if you are facing any issues, you can drop in the comment section. Now let me show you the hardware connection and how data is being shared. Now initially here you can see, right, no data is shared. So now let me connect my ultrasonic sensor and all. Yes friends, I have compiled successfully. Now I have connected my NodeMCU with my laptop using the USB connector. This is my ultrasonic sensor. You can see there are 4 pins. VCC you can use either to 3.3 volts or VIN. In VIN we are going to get 5 volts by default due to this USB connector. Ground to ground. Trig, as per our program, you need to give trig pin to D2 and echo pin to D3. So now let me give the connections. Yes guys, I have given connection successfully. Black wire I have given to ground. Ground to ground we have connected. If you can see here. Brown wire is nothing but for voltage. 3.3 volts I have connected. And this both white wires belongs to trig and echo. You may get confused. So again and again I am saying. As per our program, trig pin is connected to D2 and echo pin is connected to D3. You can count also if you want. Yes, for D2 and D3. Now I have also uploaded the code, and if you have not uploaded, just click here, then open serial monitor. Here you can see data is being shared to ThingSpeak. So let me open my ThingSpeak account. Yes, here you can see for every 15 seconds the values are being printed. Yes, now slowly it runs because directly if you open ThingSpeak it takes time. Here you can see the default distances, right? 62 centimeters and all. So now I am keeping my hand here. So now for next 15 seconds I will keep like this only, so that the distance will be reduced. We will wait for 15 seconds. Yes, here you can see 4.36 centimeters came, right? So now here in ThingSpeak you need to wait because it takes 15 seconds, right? Yes, the first, yes, here you can see suddenly there is the downfall. From 0 to 10 range only, right? 4 is here you can see 4.35. I hope, yes, here also you got, yes, 4.36, yes, approximate values. So this is how the data is being shared from our sensor to NodeMCU and from NodeMCU to our ThingSpeak account. Here you can see, right, actually for temperature sensor also will get similarly like up and downs. I think there is some small issue in my sensor actually. Yes, one more thing is that while working with NodeMCU, remember guys, if this part is there, right, this Wi-Fi module, if it gets seated, you should wait for execution. Otherwise, you can't execute any program. Now you can see, right? Yes, you can see continuously the datas are being coming. Here again I am keeping my hand. So again there will be some down. Let me keep at this altitude this time. Instead of 4 centimeters we will be having some different value now. Wait for a while. Yes, now you can see it is somewhat near to 10 centimeters and all. This is how we have interfaced the ultrasonic sensor with NodeMCU and sending data to the cloud, nothing but ThingSpeak. So now once let me open the syllabus. Yes, this is our complete program, and here you can see on serial monitor also we are able to get. This is how it works guys. Yes, anyhow I will provide the notes and all, don't worry regarding it. So now, yes, now coming to our syllabus part. Yes, here in NodeMCU, before Azure we have covered these things. So let me mark them as green. Yes, both the things I have covered guys. Just a second, let me undo. Yes, this ThingSpeak is done. So in the next lecture we are going to do with Azure, and after that we are going to work with real-time projects. Thank you. If you are having any doubts, drop in the comment section.